The experimental Flettner rotor sailboat at the University of Rhode Island is shown in the picture. The rotor is example 3, chapter 8. The rotor is in diameter and 10 feet long and diameter and 10 feet long. Rotate at omega equals to 220 revolution on minute. It is driven by a small lawnmower engine if the wind is a steady and both knot wind. Kiloknot and both relative motion is neglected. What is the maximum thrust expected for the rotor? Assume standard air and water density. What is the standard maximum? Thrust expected for the rotor. Assume standard air and water. Standard air and water. We should first convert the rotation rate omega to the radian on second. In this case we have omega equals to 220 revolution on minute. So omega is 20 multiplied to 2 pi on 60, which is equals to 23 radian on second. The wind velocity is 10 kiloknot. Wind velocity, or you can write 10 kiloknot, which is feet on second. We have a diagram for this type of problems to calculate the drag and lift forces. The diagram is shown in this picture. We should first calculate the horizontal parameters for this diagram, which is a omega on u of the infinity, the wind velocity, in this case a equals to the radius of the rotor. The diameter of the rotor is 2.5, so the radius is the half of the diameter multiplies to the omega on the wind velocity, which is now we can obtain the drag and the lift coefficients. For this case we have CL two point 1.7. If we continue, for example, from this point, we can calculate the drag and the lift coefficient. CL can be obtained at 2 point and CD equals to if we continue that approximately, we have, for example, in this point we have CD, because the CD should be read from this diagram, and CL should be read from this diagram, approximately 2.5. Now we can, let me write, CD equals to, and CL let me CL 2.5. The drag force, 1 second of the drag coefficient multiplied to rho u infinity square 2BA, which can be calculated because we have the geometrical and flow specification, pound foot, and these equations also we have lift multiplies to 2BA so the total force on the boat the main purpose of this example is using the appropriate diagram for reading the drag and lift coefficients.